Today our lesson is going to be on direct variation. This kind of falls right in line with going over proportional relationships, which is what we've been doing the past few days. So make sure that you listen to the whole video to make sure you understand how to tell if it's a direct variation or not. First, we have some vocabulary. These are all probably new vocabulary words for you, so you should write these down and study them. When the ratio of two variable quantities, range versus domain, is constant or the same, their relationship is called a direct variation. This ratio is called the constant of variation. Constant of variation and constant rate of change and slope are all synonyms. Now you should know that a synonym is just another word that you can use that has the exact same meaning as a different word. So we talked about constant rate of change first. That's the same thing as slope, and it's the same thing as the constant of variation. So today when I talk about constant of variation, I'm talking about constant rate of change, and I'm also talking about slope. In a direct variation equation, the constant rate of change, or slope, is assigned a special variable k. So when we talked about slope the other day, we were using m. So when we talked about slope, we used m. Today we're going to be using k when we're talking about slope. A direct variation is a proportional relationship. Okay, so remember we talked about there's three requirements for it to be proportional. The graph of a direct variation is a line that passes through the origin. There's one of our requirements. So it has to go through the origin. It has to have a constant rate of change or constant of variation, which is this k, and the ratios also have to be the same. Okay, so today that's what we're going to be looking at. Let's look at this example, skydiving. 2 minutes after a skydiver opens his parachute, he has descended 1,900 feet. After 5 minutes, he has descended 4,750 feet. If the distance varies directly with the time, at what rate is the skydiver descending? Okay, let's make us a T-chart, X and Y. Okay, we're going to let X be minutes, and we're going to let Y be feet. Okay, so it says after 2 minutes, he descended 1,900 feet. So 2 minutes, negative 1,900. He is descending, that means he's going down, so we need to use a negative to show that. All right, after 5 minutes, he has descended 4,750 feet. So 5 minutes, he's now descended 4,750 feet. Okay, we know it varies directly, so let's see what the rate of change is so we can see the rate that the skydiver is descending. All right, so on the left, from 2 to 5 plus 3. On the right, from negative 1,900 to negative 4,750, we drop down 2,850. All right, so from negative 1,900 to negative 4,750, he goes down negative 2,850. So change in y over change in x tells me negative 2,850 over 3. Okay, and when we divide that, we get negative 950 over 1. Okay, if we divide by, which gives us 2.5. So my slope, remember that's the same thing as k. Y divided by x, y divided by x. So I've got 2.5 as my constant of variation, or as my slope. So now I can use the equation y equals kx, filling in my k, y equals 2.5x, and then I could find any value for this that I want. So y equals 2.5x, yes, that is a direct variation. Now you can check yourself, plug in any of these x values and see if you get the y out. So if I plugged in 10, 2.5 times 10 does in fact give me 25, which is what I was looking for. So you can go back and make sure that you've done it correctly. All right, let's look at the next one. In this one, let's see how it's changing on the top. 4, 6, 8, 10, it's going up by 2. And on the bottom, 12 to 16, 16 to 20, 20 to 24, it's going up by 4. All right, so let's find the rate of change, or the slope. Delta y over delta x would be 4 over 2, which would be 2. So since that's also equal to k, my equation would be y equals 2x. However, let's check this. If I plug in 4, I should get out a 12. What is 2 times 4? 2 times 4 is 8. But I wanted 12. So is this a direct variation? No. Okay, go back and check yourself. In the case of the first problem, that equation worked for those numbers. In this case, it does not work for these numbers. If we keep going down to 0, you would see that 0, 0 is actually not part of this table. Okay, so make sure you go back and check. If you plug in 8, 2 times 8 is 16, not 20. I was looking for 20. All right, last examples. If y varies directly with x, write an equation for the direct variation, then find each value. So in this case, these should be the simple ones. We're just going to find what k is and then use it in our direct variation equation. So k equals y divided by x. They told me y is 15 when x is 3. 15 divided by 3 is 5. So I know k is 5. My equation would be y equals 5x. They want me to find y when x is negative 4. So y equals 5. Instead of x, I'm going to put in negative 4. What is 5 times negative 4? Negative 20. So my y would be negative 20. All right, looking at the next example. If y equals negative 4 when x equals negative 9, find y when x equals 3. Again, k equals y divided by x. My y is negative 4. My x is negative 9. I'm just going to leave that as 4/9. So my equation would be y equals 4/9 x. They want to know when x is 3, what is y? So I'm going to leave y equals 4/9. And then instead of x, I'm going to multiply it by 3. When I do that, I can cancel a 3 here and a 3 in the bottom. So I get 4/3. Can't really tell it's a 3. 4/3, which is 1 1/3. Now, over the past few days, I've told you not to change improper fractions to mixed numbers. But in this case, when we're solving for x or y using direct variation, you do want to change that to a mixed number. Now leave k as a fraction. We want to leave it as a fraction, but you can change y to a mixed number. So 1 1/3 would be the best answer there. All right, right now I need for you to open your book to page 355, complete numbers 10 through 21, omitting 11 and 13. So do not do 11 and 13, but do all of 10 through 21 other than 11 and 13.